Students, the next topic is based on the prefix codes and the weighted trees under the concept of Introduction to Graph Theory. So before we start with the example problems, let us see what is a prefix code. So prefix code is nothing but in which if no sequence in P, that is nothing but prefix, is the prefix of any other sequence in P. If no sequence in P is the prefix of any other sequence in P, So the meaning of prefix code is it is a sequence in P. For example, let us consider this sequence. Okay, I'll just take the consideration of this sequence, that is 10, 0, 1101 111 followed by 1100. So this is a sequence. One is this P1 set. This be the second set, that is P2, 0, 1, 0, 1, 0, 1, 0 and 1. Okay, let these be the two sequences. You have to check whether it is a prefix code or not. So a prefix code is a sequence if in P the prefix of any other, if there is no sequence in P of the prefix of any other sequence in P. That means, now for example here 10 is there, that should not be a prefix of any other sequence. Now 10, no, it's not the prefix of this. Here also 10 is not there, 10 is not there, 10 is not there. 0 also, it should not be the prefix of anything, no. 1101, 1101, entire thing should not be prefix of somewhere else, no. 111, no. And these all are separated. So prefix code is nothing but it is if you don't have any sequence, if no sequence in P is the prefix, if no sequence. Now if no sequence in this is of any other sequence prefix, that means if this is not the prefix of any other sequence in this. So there are 1, 2, 3, 4, 5, 6, all should be different from each other. Like 10 should not be a prefix of any of this. Consider this particular, so this is a prefix code. Consider this particular P2 here, 0, 1 is there, but again that 0, 1, in that just 0 is there, right? That is a prefix of other sequence. If you check over here, 0 is the prefix over here. So this is not possible. Again 101, your 10 is the prefix over here. Whereas if you check over here, if you just check over here 10, 111, you don't have any sequence. Again 10 is there, 10 together you don't have anywhere, it's in between, just 0 is not there. So over here 10 is one sequence, that is a prefix of something else, not there. Okay, so even if you take 1, it is a prefix. 1 is a prefix over here, just 1. So this is not a prefix code. So a prefix code is nothing but there should not be any sequence in P being prefix of any other sequence. So that is an example and the definition of the prefix code. Now here in this they are told, consider the prefix code A11, B0, C 1100, D110 and E10. Using this code, decode the following sequences. Decode in the sense you need to put these alphabetical orders. Okay, using this code, decode the following orders. So the first one we need to split this. So it is 110. It is already a prefix code, then obviously there should not be any prefix of these. So you can see 0 is not there anywhere as a prefix, and 111 is not there anywhere as a prefix, and this itself is not there anywhere as a prefix, and 10 is not there anywhere as a prefix. So these all are the prefix code. So the first number whatever is there, 10000 followed by 111101. So for this you have to decode the code. Using this you have to decode the code. So for this it would be 100. Check for 100 anywhere. 100 we don't have, but for 10 we need to split this. So it is 10, 10, and then check for whether 0, just 0, 0, then anywhere 1, 111 I can consider, 31, 10, then 31, then I have 101. I mean 31, then followed by this 110, that is 1101. Now this is nothing but 10 is E, 0 is B, and 111 is A, and 1101 is D. So this can be decoded into EBAD. So this is first sequence. For the second one it is 10. followed by 4 ones, 1 2 3 4, and then again followed by 2 zeros and 1 1, then again followed by 3 zeros, 1 1 0 1. Okay, 1 1 0 1. So this is regarding the so this is regarding what is the code. Now for this again we have to split up and find out. So it would be 1 0 anywhere the code is there. Yes, 1 0. Then again I'll take the different ink. 1 0. 4 ones anywhere. No, we have 3 ones. So let me take 3 ones again. I'll split it into 3 ones. After that again 100. For 100 I don't have anything. But for 1 0, I mean 3 ones, followed by 3 ones, then followed by 1 0. You can take it for 1 0, that is E. Again 1 0. Then you have 0 1 double. So again you can take 0 separate, 0 separate. This is done. Then again 1 1 double 0 I can take. 1 1 double 0, 1 1 double 0, and then you can take 0, just 0. Take this 0, and then again 1 1 0 1. This you can take entirely. 1 1 0 1. So I split it up this. I think 1 1 0 is 1, no, 1 1 0 1 1 0 0, and then again 0 1 1 0 0 1. So this would give me 1 0 is E, 1 0 is E, and 111 is A. Then again 1 0 is E, then again B, 1 1 0 is C, then again 0 is B, E A E B C B, and last one is D. So this is regarding the second one. And the third one, decoding, would be 1 1. I'll just write exactly 1 1 0 1 1 1, followed by 6 ones, right? 1 2 3 6 ones, and then again 0 0 1 0. So this would give me 1 1 0 followed by 6 ones, again 0 0 1 0. So this 1 1 0 would give me 1 1 0 would give me 1 1 1 1 0. Just single 0? No, I have just 1 1. So I can take this 1 1 0 1 section. No, 1 1 0 1, anyway the combination is there. Yes, 1 1 0 1 combination is there. So I'll write 1 1 0 1 combination, then followed by 3 ones I can take. So this 3 ones I'll take 1 combination, 3 ones, and then again I have, so till here is done, this 3 1 1 0 0 1 1 0 0 1 1 0 0 is C, then again 1 0 is E, 1 0 is E. So this can be written as 1 1 0 1 is nothing but D, 111 is A, and 1 1 0 is C, and 1 0 is E. So this is the decode. Using this code, decode the following. So this is decoding what we have done. So this is regarding the example 1. All these are actually, they have told the prefix code itself. So when you see the prefix code, all these prefix code are individually different. So nowhere this prefix code forms a prefix for anything else. So in this sequence there should not be any prefix of existing code. So this is regarding the example 1. In the example 2, a code for A, B, C, D, E is given by A00, B01, C101, D X value, and 10 E, Y, Z, where X, Y, Z belongs to 0 or 1. Determine X, Y, Z, X, Y, and Z so that the given code is a prefix code. Okay, so we have to check, determine the value of XYZ so that the given code is the prefix code. So we know A, B, C. So if X can take the value of 0 and 1, Y can take the value of 0 and 1, and Z can take the value of 0 and 1. If we take X equal to 0, what would happen? If we take X is equal to 0, then we would get 0 1 0. So 0 1 0, check anywhere prefix is there for 0 1 0. Yes, 0 1 is there. 0 1 is there, so which contains the code 0 1 for B. 0 1 is B, nothing but it is taken as a prefix. Agree? So X cannot be 0. If you take X is equal to 0, then this cannot be a prefix code. We should get a prefix code. So 0 1 is taken as a prefix, right? So if you put X as 0, 0 1, which is a prefix already there in a sequence, so I cannot take X is equal to 0. Next we'll try for X is equal to 1. When you try for X is equal to 1, you will get it as 1 1 0. So whether 1 1 is there, 1 1 0 anywhere, nowhere else. So we can take X as 1 1 0, X as 1 1 0. So what we'll do is, if we take X is equal to 0, then then the code for D reads 010, which contains the code 01, which contains the code 01 for B as a prefix, okay. So if we take x is equal to 1, then D is nothing but 110. So this is acceptable. Now for y and z. So for y and z we can take 4 possible values, that is y equal to 0, z is equal to 0, y is equal to 1, 0, z is equal to 1, and y is equal to 1 and z is equal to 0, and y is equal to 1 and z is equal to 1. We can take these values. So let us try with all these values. If we take y equal to 0, z is equal to 0, y equal to 0 and z is equal to 0, then it would be 001. So 001 already prefix is already reads, which contains the code for A as a prefix, okay. So we cannot take 00 because it already, then if we take 00, then the code, if we say 00, then the code for E would be 001, which contains the code 00 for A as a prefix, so that cannot be considered. Okay. So if we, same thing, I'll just put a double quote. If we take y is equal to 0 and z is equal to 1, y is equal to 0 and z is equal to 1, then the code for E, I'll just put repeat, okay, over here, for E would be 011. Okay, but 01 is again the, if we check over here, 01 would be 011, which again double quote, which contains the code 01 for B as a prefix. If you check here, for B as a prefix, double quote, okay, for B as a prefix. Again, if you take y is equal to 1 and z is equal to 0, then the code would be y is equal to 1 and z is equal to 0, then it would be 101, which is again C itself. Then the code for E would be 101, which contains 101 for C as a prefix, okay. So these three possibilities is not possible. So y is equal to 1 and z is equal to 1, the code would be nothing but 111. The code for E is 111. So you don't have any prefix, therefore with the choices of x, of x, y, z, above the codes can be, I'll write in above statements, okay, I'll write over here, the codes can be A is 00 itself, B is 01, C is 101, D is 110, and E is 111. So this is the result. So this is, in this concept you will understand regarding the concept of prefix code. Let us go to the example 3. Here, obtain the prefix code represented by the following labeled complete binary tree. So if you remember, in the binary tree you have the left branch and the right branch. Whatever the left branch will take the value of 0 and right branch will take the value of 1. Now what they have told is obtain the prefix code represented by the following labeled binary tree. That means you have to obtain the prefix code of all these leaf nodes. So the leaves of the given tree are represented by the symbol, the leaves of the given tree, are represented by the symbols A, B, C, D, E. So For this you have to find the code. So for A, thus the leaves are identified. Thus the leaves are identified by following by the sequences. Okay, for A you just find the sequence. So the leaf is the A. For that sequence you find what is there for A. 0 0 0. If you just check here, 0 0 0, so it is 0 0 0. For B it is 0 0 and the branch is right branch, so it is 0 0 1. For C it is 0 1, that is this and this. For D it is 1 0 1 0, and for E it is 1 1. So this is how we are going to find the code. I mean, you're going to find the prefix code for these leaf nodes. So this is combination of this as well as this. We have the complicated problems in the next example. So you should know how to put the left branch the 0 value and how to write down the right branch the values. So 0 1 0 1 0 1 0 1, and then finally how to calculate the prefix code for these leaf nodes. So it is full left branch, and then again left, and then again right again. Then you're going to find 0 0 1 0 1 1 0 1 1. So this is regarding the example 3. Example 4, find the prefix code for the letters B, E, I, K, L, T, P, S if the coding scheme is as shown in the figure below. So this is the figure given. So based on this figure, you should find the first job is you have to find the codes for this. Once you find the codes for the words pipe and vest, then decode the string. So this is given. So this figure is being given. Find the prefix for the letters B, E, I, K, L, T, P, S. So I'll just write over here. For B it is 3 zeros. For B it is, you can just check over here. For B it is nothing but followed by the 3 zeros. Okay, for B it is 3 zeros. So just write over here. Okay, this is the leaf and that code, whatever the code for that. For E it is 001 001. For I it is 01, and for K it is 1100 1100. For K it is 1100 1100, and for L it is 110 right branch. So L it is 1101, and for T it is 111, 3 ones followed by zeros, 1110. That is this one, and this 0. And for P it is 11110. For P it is 4 ones followed by zeros. For S it is all ones, 1 2 3 4 5, 1 2 3 4 5. So this is the codes for all these letters. So we found the first. In that again A solution is find the codes for the word pipe. So for pipe it is you have to use P. So that is 1 1 4 1 0. I use the code P, and then again I is 0 1. Okay, I is 0 1, and then again pipe. Then again you're using 410 11110. Then again E code. E is 001. So this is for the pipe. And for the best, best it would be B is 000 1 2 3. For E it is 0001, and for S it is all ones, so it is 5 ones, 1 2 3 4 5, and for T it is 1110 1110. So this is regarding the first. Find the codes for the following. Next we have decode the string. So for B, in that first one is 1 2 3 4 followed by 3 ones followed by 1 2 3 4 1. So you can split it into 3 zeros. I'll take the different color. You can split it into 3 zeros. Check here where you have 3 zeros. So I can split it on 3 zeros. Okay, then again 0 111 anywhere is there. You just check to 0 111 0 000. I did 0 111. I don't have 0 111. I have 0 1 over there, so I'll split like this, 0 1, and then 1100 1100 K is there, 1100 K is there, 001 E is there. So 1100 0 0 1. So this would give me, this is nothing but 000 is B, this is I, this is K, and this is E. So it would give me bike. Similarly, in the second section, the second section is this number. So it is how many numbers? 1 2 3 4 5. 1 2 3 4 5 6 7 8 9. I think it is 9. 1, yeah, it is 9. 1 2 3 4 5 6 7 8 9, followed by 0, again 1 1 0 1 0 1, again last 1 1 1 0. So this can be split. Check for 5 ones anywhere, continuous one, it is S, it is 5 ones. So I'll change the color. It is 5 ones, so I can put 1 2 3 4 5 ones together. After 5 ones, anywhere 4 1 zeros. Yes, 4 1 0 is nothing but P. So I 1 2 3 4 0. So till here it is done. 1 1 0 1 1 1 0 1. Yes, L is there. So 1 1 0 1. After that 0 1. Anywhere 0 1 1. No, just 0 1 you have, that is I. Then you have 1 1 0, that is T. 1 1 1 0. So this would give me, this is S, this is P, this is L, this is I, and this is T. So it would give me split. It would give me split. So this is regarding the example 4. Next, from this is a very important concept. From these three problems are very important. That is example 5 and example 6 and example 7. So what they tell is construct an optimal prefix code. Now this will be given and their weights will be given. Okay, this is the code, leaves, and their weights will be given. You need to construct tree in each iteration and find the optimal prefix code tree. That means again you have to find the code of these prefix. So while solving, you will come to know regarding this. So let us just, I'll just tell you regarding the statements what you're supposed to write over here. First, what you're going to do is construct an optimal prefix code for the symbol A, O, U, Q, O, Y, Z is there. So these, treating the given frequency, whatever is there, right? The non-decreasing order you have to arrange. That means increasing order you have to arrange from smaller to the bigger one. So check for this. A is 20, O is 28, Q is 4, U is 17, Y is 12, Z is 7. So from there, you just write down the statement. Treating the given frequencies as the weight. Whatever these is there, right? That is the weights of the leaves of the corresponding symbols. We first arrange those in the non-decreasing order. So just write on there. Treating the given frequencies. Treating the given frequencies as the weights. Treating the given frequencies as the weights, and the corresponding symbols as the isolated vertex, and the corresponding symbols as the isolated vertex, isolated vertices. We first arrange the symbols such that their frequencies are in non-decreasing order. That is nothing but increasing order from ascending order, okay, non-decreasing order. So what their main job is to construct optimal prefix code. To construct an optimal prefix code, whatever the symbols is given, their weights is also given. So whatever first step what we have to do is from the least to highest we are going to order. First you have to order from the least to the highest. Okay, so after that, after this treating the given frequencies as the weights, these are the weights of these corresponding symbol. Let us arrange this in the non-decreasing order. So this would be a first step. Okay, this is shown below. That this would be first step. This is shown below. That is, which is the smallest one? Q is the smallest one. So we'll write Q and their corresponding weight within the bracket 4. And then you have Z and the corresponding weight of Z is, minimum is Z, right? 7. And then again you have 12. 12 is y. Y is 12, and then you have u, that is 17. U is 17, and then you have a, that is 20. A, that is 20, and then you have O, that is 28. So this is the first figure you're going to get over here. Now using this, what you will do is you will combine two each. Again what you will do is, this is the step 1. Okay, this is the step 1. This is the step 1. Now this is in the increasing order, or in the ascending order, non-decreasing order. Okay, now what you're going to do is, now you should construct an optimal tree having QZ all these as leaves by using the Huffman code procedure. Now this is done step by step by using the graph method. Now what will be the first step over here is, now minimum whatever is there, that you will combine and form one tree, that is Q and Z will be whatever the weights is there, 4 and 7, right? I'm just showing over here 4 and 7, that will form one new tree vertex by adding these weights. So it is nothing but 4 plus 7 would give you 8, 9, 10, 11. Okay, this would give you 11. This would give you 11. So again it will come in the first branch itself. So here when you see over here, these two are combined and formed a tree. So new vertex V1 will be formed, where Q is having 4, where Z is having 7, and this 11 again it should be arranged in the non-decreasing order. That means 4 and 7 is already used, so V1 will come first, and then U, this is U, A, O. So we'll solve in the next page, you will get a better idea. I'll repeat step 1 over there because you'll get confused. So step 1, what we had is, we arranged that in the non-decreasing order. So Q we had 4, then we had Z as 7, then Y, that is 12, then we had U, that is 17, then we had A, that is 20, then we had O, that is 28. Okay, QZ Y U A O. This was a step 1. Now step 2, as I told, we are going to construct. Now anymore it is step by step graphs we are going to generate. Now we are constructing optimal tree. Okay, from step 2 we are constructing optimal tree. We are constructing optimal tree. Optimal tree having QZ Y U as leaves, having Q, Z, Y, U, A, O as leaves, by using Huffman's code procedure. By using Huffman's code procedure. Okay, this we are going to do the step by step, and finally this we are going to do the step by step procedure, and then finally we are going to form a tree. So let us draw the tree. Now in this minimum is 4 and 7 when combined. So you should, from step 1 is you combine these two vertices or leaf nodes and from a new vertex and find the weight. When you add 4 plus 7, first you add 4 plus 7, that will give you 11, which is less than this. So that is a new vertex called V1 with the weight 11, whose left branch is Q, whose right branch is Z, and with their weights you are mentioning 4, 7, followed by at the same level. Now this is being covered, you'll just mention Y, their weight is 12, and then you have U, whose weight is again 17, and then again you have A, whose weight is 20, and then again you have O, whose weight is 28. This is step 2. Repeat this step again. Minimum 2 you will take and form again one more branch. Minimum 2 you will take again and combine one more branch. So here in this level you are taking as all these are one level. So 11, 12 will give you 23. Okay, 11, 12 will give you 23, where that vertex, new vertex should be placed next to because this and this is done already. Now you are combining these two vertex. So when you combine these two vertex, V2 will come. That V2 should appear. V2's weight is 23. V2's weight is 23. So it should come next, not next to U, not next to A, next to A it should come. Here that V2 should come with the branches these. So U will be first, A will be first, and V2 will be over here, then O will be there. So step 3 would be U and A will be appearing first. Let us combine these two and we'll put O here. Okay, that is V2 V2. For that V2 add these weight, 11 plus 12 will give you 23, and the branches will be like V1. Okay, one branch is V1, right branch is Y. For Y the weight is 12, for V1 the weight is 11, and this branches remain same, that is Q and Z. For Q the weight is 4, and for the Z the weight is, for Z the weight is 7. For Z the weight is 7. So I just combined these two. One I took left branch, one I took right branch, and put a new vertex V2, summed these weights 23, and this branch would repeat same V1 with Q and Z. So V2 is 23. Now check for these, this job is done. These two combined. Check for U whether it is less than 23. Yes. Check for A whether it is less than 23. Yes. So at this same level put U. U would be like, U should combine first, U17, A with 20, V2 we combined and wrote over here. Next left out is O with 28. Next what we have to do in step 4 is again combine two vertex with the non-decreasing order. That means this. So I'll just draw over here. So that next page again you will get confused. So step 4. We should combine. Now V2 is done. V3 how much you'll get? Add V3. 17 plus 20 will give you 37. So it should come at the last dead end. That is V3, and V3 weights would be, V3 weight is 37, and here it would have one branch as U, that is 17, and one more branch as A, that is 20. 37 is the last. Next to that is these two branches. Still same tree you're going to draw again. That is V2 had 23. For that V2 you had V1, that is with 11, and one more you had Y, that is 12. And for this V1 again you had Q, and then again you had Z. With the Z weight is 7 and Q weight is 4. Okay, and one more is O. O is just a vertex, 28. O, now you have V2 28, O 28, and V3 37. Next again what you two vertex you have to combine. So that and this will combine. Okay, that I'll do in the next page, or else I'll do over here itself, otherwise you'll get confused. Step 5. Okay, step 5, check the weights 23 and 28, 37. These two are less, so 23 plus the 28 would give you 28 plus 38 would give you 51. Yes, yeah, 51. So this would give me 51. Step 4 would give me 51. So this 51 should come next to this. So first draw as it is this vertex. So it is V3 with 37. And here again the branches U with 17 and A with 20. So this is one. Now the new tree, what I'm doing, the combination of combination of 23 and 28 would be nothing but new vertex. V3 is already done, so V4. For that V4 two branches. One is V2 itself. This entire branch you draw, that is 23. For that again you have V2, for that again you have V1, and this side you have Y. Okay, same entire left branch you place this V2, entire this left branch you place V2. For that V2 had V1 and Y, I wrote over here. For that again V1 you had Q and Z, right there weights. Q had 4, Z had 7, V1 had 11, and Y had 12. Okay, and for this V4 new, I had to combine with O, right? So that would be over here, O 28. Now done. V4 weight was 51. Okay, now last step would be combination of these both trees. So I'll draw that in the new page. Step 6 would be combination of these both trees. So that is nothing but V5, sum of both the vertices would give me 88. Okay, that is nothing but 88, and whatever that final vertex you're going to get, right, that you write it in the sense that you write it in terms of root itself. Now when you see over here, the last vertex would be nothing but combining these two vertex, right, that you take it as root itself, just putting on this, and then this branch and this branch remain same. Just combining these two and put one root, add these vertices, then it should be same left branch and right branch. So in the left branch you have V3, and in the right branch you have V4. So V4 had 51, V3 had 37. For this again you had two branches, that is U and A. and that would give you 17 and 20. 17 and 20. Okay, 17 and 20. And then for V4 51, right? So over here you have O as well as V2. I mean V4 again you had two branches, V2, that is V2 is 23 and O is 28. Then again with this combination V2, you had V1 and Vy. V1 and V1, that is 1 1, and Y, that is 12. Then for this V1 you had again two branches. So that is nothing but Q4 and Z7. Okay, I'll just erase this because no confusion. These are two branches at the same level. So this was V1 with 11 weight. So that had Q as well as Z. So this was the final tree what you're going to get. Now whatever this tree is there, right, that is again the final tree. Now this tree should be represented in the terms of Huffman tree. When you represent in terms of Huffman tree, all these vertices again, whatever these leaf nodes will be represented, and zeros and one values will be put. So I'll write over here the tree shown below. Next, whatever the final tree you're showing, the tree shown below is an Huffman tree. Huffman tree is nothing but optimal tree you're going to find. Huffman tree is nothing but, within the bracket you can tell that it is an optimal tree. Optimal tree you're going to obtain for the given data. Okay, for the given data. So this would be the tree. So you have again the root node, as it is you'll mention the root, and then you had branches. Whatever that V4, V1 you have written, right, eliminate. You're not going to mention that because you just want to find the weights of U, A, all those things, whatever is being specified. So U and A, this I just skipped. From V4 you had to O, okay, and then you had V2, one branch, and then from V2 you had two branch, one is Y, and from this was V1, from that you had one branch, Q and Z. Now you just put the values, wherever is left it is 0, wherever is right 1. So this was 1, this is also 1, and this is 0, this is 0, this is 0, this will be 1, and this will be 1. Okay, now for this you have to find the codes. This is U, this is A. Now this is an optimal tree. From this optimal tree, the prefix code for the symbols would be, the prefix code would be, for U it is 0 0, for A it is 0 1, for U it is 0, this is U 0 0, for A it is 0 1, for O next level is O, for O it is 1 1, for Y you can take anything, you can take Y also, so it is 1 0 1, or else if you want to see the alphabetical order whatever it was given, okay, if you see the question A O Q U, like that also you can go, or anything, anyhow how you have ordered also you can go this way also, O, and then for Y you take Y, it would be 1 0 1. If you check for Y, it would be 1 0 1, and Y is done, O is done. Now for Q it would be 1 followed by 3 zeros, for Q it would be 1 followed by 3 zeros, and for Z it would be 1 followed by 2 zeros and 1, 1 0 0 1. So this is the prefix code, and this is the Huffman's tree, or it is an optimal prefix tree. So this is an example how we are going to find the prefix tree. So I'll just repeat the problem. They told construct an optimal prefix code, which means you have to construct optimal tree. From that optimal tree you have to going to find the prefix code for the symbols that occur with the respective frequencies of this. What we did is, first job is whatever with the lowest frequencies we arranged. That means in the increasing order I arranged over here. I combined two leaves and found new vertex and checked their weights. 4 plus 7 is 11, which is less than all these weights. So again it came to the first branch. V1. Okay, next I combined these two weights, so it is 23. So 17 20 23, again arranging in the order 17 20 23. So it came over here. So next level was this and this should be combined, 37, but which is greater than this and this and that. So it came over here. If you check over here, Okay, and the next, what is 23 and 28 got combined, whose weight was 51, so it came over here, and 37 came over here. Okay, and then finally combined both the branches and I found this. And when you do optimal tree, I'm just eliminating these vertices and their weights. I'm just representing the leaf node what is over there.